Normally, junction diodes are manufactured from a single piece of silicon, which has had p-type doping at one end and n doping at the other. The circuit symbol shown at the top of the diagram gives a clue as to its purpose. It will conduct a conventional current in the direction of the arrow, but has a very high resistance in the reverse direction. They function very much like a tire valve that allows air into a tire but not back out again. The diode will allow electricity to flow one way but not the other. Indeed, the first diodes were called valves, although they did not look like this. Modern diodes are tiny, whereas the originals were large, glass, and very fragile. In order to examine the properties of a diode, we will use this circuit. This will allow us to change the potential difference applied to the diode and record the current flowing through it. If we place the components onto the circuit, you will be able to see in slightly more detail how it will work. The value of the potential difference can be changed by altering the potentiometer control, and the current can be recorded on the ammeter. We start with the value of the potential difference turned to 0, and then we will gradually move that up. You can see that in spite of there being a significant potential difference, which we will gradually increase, no current is recorded on the ammeter. As we increase the potential difference further, there will be a point at around 0.55, 0.6 volts where the current begins to be measurable. I have recorded these readings so a graph can be drawn at the end of the demonstration. As the potential difference reaches a 0.7 volts or thereabouts, the current rises much more rapidly. The point at which this change starts to occur is often called the threshold voltage. As both the potential difference and current rise, the ratio of potential difference to current, which is of course the resistance, decreases sharply. If we make a note of these final readings, we can then tabulate the whole of the results, and from that we can draw a graph of potential difference on the x-axis and current on the y-axis. If we then add the line of best fit, we can see the sudden increase in current as the potential difference rises, particularly beyond about 0.65 volts. A junction diode most certainly does not follow Ohm's law. It was not part of the demonstration, but if we reverse the potential difference and then increase that to about 50 volts, the diode will eventually break down and conduct a current in the opposite direction. It will, at the same time, destroy the component. However, the total graph would look something like this. Thank you for watching. Notes are available from the website.